In this first video, we're going to go through the overview of just some basic terminology, and then we're also going to talk about the different methods of sampling and also the different types of study that are involved with sampling. When we start with statistics, one of the first things that we have to be cognizant of is the process of why we're utilizing statistics. And generally in statistics, much like any other sort of scientific inquiry field, we try to identify some sort of question, some sort of problem, or come up with some sort of hypothesis. Then what we do is we collect data based on that hypothesis or that question. Statistics is the idea of how we collect that data. And then how do we organize and summarize that data? And then finally, how do we aggregate or how do we interpret that data? Right? So the very definition of statistics is that it is the branch of mathematics that involves organizing, collecting, analyzing, classifying, and interpreting raw data. And so whenever we try to collect these types of data, there's actually two branches of statistics that we're going to be interested in, and we're going to study both of those throughout the course. One of them is probably a branch that you're most used to, being able to summarize data and organize data. And you might have done this with Excel, or you might have done this by hand in another class by creating bar charts, pie charts, frequency distributions. And if you haven't, that's not a big deal. That's called descriptive statistics. So descriptive statistics is exactly what it sounds like. It describes a sample, it describes a population, and it tells us what we already know about that. In other words, we might have collected data, and what do we know about that data? All right. Now, what if for some reason we want to expand upon that? We want to forecast. In other words, what do we think is going to happen? Well, that's another branch of statistics. That's called inferential statistics. And inferential statistics is the idea that we might use a regression line, or we might use some sort of curve, or might sort of forecast what may happen. All right. So if a business knows in the first 5 years they've been increasing steadily about $3,000 profit each year, they might forecast somewhere along the lines of having $3,000. Right? Now, within these two different branches of statistics, we have obviously the most fundamental component of everything that we're looking at, and that's just data. Data is going to be our information, all right? And it's about some variable of interest. In other words, heights of males, or maybe the number of cars that are parked at the Hartford Community College Library or something of that nature, all right? It's just basically raw information that hasn't been aggregated, hasn't been sorted, anything of that nature. Two different types of data that we're going to classify. We have this categorical data. And categorical data is data that can be described by an adjective. So for instance, you might say the color of a shirt, or maybe the type of car, your major. Okay? Those are all different descriptions of categorical data. In other words, you can count how many there are, but you can't necessarily assign a number to it. All right, like for instance, your major, you can't say that my major is 6.5. You would say that your major is criminal justice or education or mathematics or something of that nature. The data that can be described using numbers is going to be called quantitative. And quantitative data is the data that we can find averages for, standard deviations. So if you've ever done those before, or those sorts of computations, that's what we're going to be looking at. So for example, your GPA is generally a quantitative data or a quantitative item. And to be in an honors course, you have to have a 3.20 or better GPA. So that's one measure of quantitative. Your speed on the highway is another measure of quantitative data, or is another type of quantitative data. The number of milliliters of blood in a vial, that would be another measure of quantitative data. All right. So categorical is described by an adjective, quantitative is described numerically. Now, a lot of times we can't collect all of the variables of interest, and that's where we're going to start talking about this idea of sampling. All right, so right now we have two different types of groups. We have this idea of a population. A population is all the variables that we're interested in. Okay, so a population might be all students in the HCC honors program, or it might be, let me try not to use students, it might be all animals in a zoo or something of that nature. Okay, it's basically every possible observation that exists. A lot of times we can't collect all those observations, so we like to use a subset of the population called a sample. So in other words, if I were to take maybe 5 of the students in the HCC honors program, or maybe all the penguins in the zoo, that would be an example of a subset of the population. And then we have just one single element of data. That's called an observation. An observation is just one record. So for instance, in our population of HCC students in the honors program, and maybe we took 5 of those, maybe we take a look at one person and we try to observe those in the behavior. Sometimes we're interested in the characteristics of the population. Sometimes we're interested in the characteristics of a sample. If we're interested in the characteristics of a population, that is called a parameter. So a parameter is a numerical characteristic of a population. So for instance, the average GPA of honors students at HCC, right? That would be an example of a parameter. And then a lot of times we can't gather parametric data or parameter data, so we look for statistics. And a statistic is a numerical measure of a sample. All right, so for instance, maybe I wanted to look at the average GPA of 10 HCC honors students. So hopefully that gives you a good understanding of the difference between parameter and statistic. All right, so let's go ahead and try to apply these concepts to a scenario and make sure that we understand what it is that these terms really mean in a real world scenario. So let's say for some reason a company is interested in hiring statisticians to gauge employee satisfaction. And they include items such as rating the company insurance policy, determining if working conditions are satisfactory, etc. Would this be a measure of descriptive or inferential statistics, and why? All right, so maybe pause the video, think about that, give a response, and then after you've thought about it, just unpause it, and we'll go through as to what the solution might be. And this is actually a measure of descriptive statistics, right? And the reason it's descriptive is because it's indeed describing what the condition currently is. It's not trying to forecast what's going to happen. So in other words, we are trying to measure the current condition of employee satisfaction. So anytime we take data that we already know and we try to aggregate it or summarize it, that's a descriptive measure. Another concept application. In the above scenario, the company surveys 200 employees and reports that 164 of those employees, or 82%, responded that working conditions are satisfactory, good, or very good. And is this measure a parameter or a statistic, and why? And then are we measuring categorical data or quantitative data? All right, so it may be beneficial for you at this point to maybe pause the video, think about this, write down a response, and then once you've written down a response, to maybe check back as to what the solution might be. All right, so hopefully you thought about it. This is a statistic. The reason it's a statistic is because the company surveyed 200 employees. Right? So this is a statistic, and we only studied 200 employees, but not all of them. Right? So That's why it's going to be a statistic. Now, if the company only had 200 total employees, then it would be a parameter. So it absolutely has nothing to do with the 164, but it does have something to do with the fact that there's 200 employees and it doesn't say that it's all the employees. Right? Are we measuring categorical or quantitative data? So what are we measuring in this? Well, we're measuring the response to the working conditions, satisfactory, good, very good. These are all descriptive or categorical measures because we can place them into a category but not a number. Okay, so this is categorical, and the reason it's categorical is because it's described by an adjective. Using the above scenario, identify the population, identify 3 possible samples, and then 3 possible observations. So I'll let you think about that for a moment, and then after you maybe pause the video, write down a response, and then come on back and we can compare. So a population, the population is all employees at the company. Possible samples, and your answer might be different than mine, but we could survey all the female employees, or maybe employees under the age of 30 might be another sample, or we might even interview administrators in the company, right? So those are just 3. You might have had different ones, and that's perfectly fine. But again, it's just a subset of the population, right? And then finally, 3 possible observations. Might be 1 female employee, or 1 employee under age 30, or 1 administrator. So again, an observation is just a singular entity of data. And then finally, given the above scenario, give an example of how inferential statistics could be used, and then give an example of a parameter. So I'll let you pause the video for a moment and then come back and perhaps look at my answers, so that way you can try to apply. So one possible scenario for inferential statistics, and yours might be different than mine, that's perfectly fine, might be that we use the survey data to predict next year's climate or employee satisfaction. When I say climate, I don't mean weather climate, I mean the climate within the business. And then an example of a parameter might be the average age of all employees at the company. Okay, that might be a parameter that we could use. Another one might be the average, or the percent of all, I'll try to stay away from average this time, the percent of all employees that responded satisfactory to a question. Okay, so that's a parameter as well. A parameter doesn't always have to be a percentage. It could certainly be an average, and it doesn't always have to be an average. It could certainly be a percentage. All right, so hopefully this helps out a little bit into understanding some of the introductory terminology. In the next section, what we're going to do is we're going to take a look at the different ways that we're going to collect data.